dictionary. So physical AI is really AI that's interacting with the physical world through sensors and actuators. The role DePIN can play to really lower the cost of development of these systems. Challenges of scaling physical AI is enormous capital and R&D investment, and DePIN as a technology provides a way to really accelerate that by building out infrastructure services like Geodnet, but also helping with things like mapping and training data that are needed to bring these services up in different environments. You can imagine if I take that car in San Francisco and I move it to New Delhi, it's just not going to be able to drive effectively without a tremendous retraining. This is where DePIN can come in as a data collection layer, as an infrastructure layer to provide services and make these solutions much more scalable. You can imagine like a robotic lawnmower in your lawn. Even a few centimeters of error in its position is the difference between mowing your lawn and running over your flowers. So hyper-precise location is a very powerful tool in the development of robotics. You can build maps from that. You can do obstacle avoidance. You can work in conditions where you might have no visual line of sight. So some things like cameras and lidars are also super powerful sensors, but they have weak points in terms of lighting conditions and types of materials that they may not bounce off of well. So RTK, real-time kinematic, is a way to sort of blindly know where you are to within a centimeter.
Geodnet delivers centimeter-level precision through RTK, real-time kinematic, for physical AI applications like autonomous driving, drone delivery, precision farming, and other high-accuracy use cases. With over 13,000 active satellite miners, Geodnet is now the world's largest RTK network, surpassing centralized providers such as Trimble, generating $3 million in annual recurring revenue from RTK subscriptions.
Well, I would like to get your take, Mehdi, on the whole DePIN. Why hasn't this narrative kicked in faster? Because to me, it's one of the most obvious utility generating things in all of Web3.
One thing I would primarily say is distribution of the token. One mental model is thinking over the product and the token separately. For whatever reason, it has been a little bit of a struggle for DePIN to get that token distribution with the exchanges. Tier 1 exchange listings that basically gets the token into the hands of other people. If people make money, they speak about it, that has that momentum. There's a blessing and a curse with revenue as well. So one thing that happens in crypto is, let's say if you have revenue numbers, people can start attaching fundamental valuation to it, which is great, which is awesome. You should do that. But let's say if you don't have valuation, if you just have story, there isn't a valuation, and basically sky's the limit. Hey Mike, welcome to the Coordination Games.
Hey Mehdi, how are you doing?
Mike, it's good to have you here. So Mike, to kick things off, why don't you tell our audience a little bit about who is Mike, how did he get into crypto, and what is he building?
Yeah, so my name is Mike Horton. I'm the project creator of the Geodnet network. And Geodnet is a hyper-precise localization and positioning service used by things like drones and robots to know where they are in the real world to centimeter accuracy. So XYZ positioning of about 1 centimeter. I got into Web3 purely from the autonomy and robotics side. So this problem of being able to do precise positioning has been around for a long time. And one of the key technologies needed to make that happen is to have kind of local base stations, what we call satellite mining stations, pretty short range from the robots, within 20 kilometers. So you need to have this infrastructure built out all over the world to provide this type of service. And we saw that doing that in a traditional Web 2 way was going to be enormously expensive and running into the billions and billions of CapEx. And we looked to DePIN, we looked to token incentives as a way to create that infrastructure. And we've now built the world's largest such network on the planet by a couple factors here. So it's been a very successful way to create infrastructure for robotics and drones that previously didn't exist.
Mike, we'll double click into the traction part. I know the number of base stations you have now has grown exponentially. You might be one of the largest RTK network out there. Before we jump into that, one thing I've seen you speak lately about is physical AI. So for our audience, can you tell us what is physical AI in your opinion, and what role DePIN can play in physical AI?
Yeah, so physical AI are things like robots and drones and self-driving cars that are using AI technology, but are also interacting with the physical world to do physical things. So replacing physical work, replacing driving a car. These rely on a lot of sensor technology to provide the inputs to AI in order for the AI to be able to effectively work. These devices are some of the most complicated in the world today, but they also offer incredible value. I mean, logistics, transportation, automotive, aviation, these are just enormous markets that drive enormous costs, and being able to do that with AI-based devices is quite revolutionary. So physical AI is really AI that's interacting with the physical world through sensors and actuators. The role DePIN can play, I think, is to really lower the cost of development of these systems and to make them work. So to scale these things out on a global basis, you need tremendous compute and you need tremendous physical infrastructure services to provide connectivity, localization, mapping for these devices. And so the instances where they've been successful so far, like produced by centralized companies, have been enormously expensive. We can take, as a good example, Waymo, which is a really first full level 4 autonomous car service that's in full operation, but it's only in operation currently in 3 cities. That would be Phoenix, San Francisco, and Los Angeles. And the cost that Google and now Waymo, as a spin out of Google, have put into that is running up over $20 billion, I think, at this time in terms of investment. So that, and to only get to 3 cities. So you can see the challenges of scaling physical AI is enormous capital and R&D investment. And DePIN as a technology provides a way to really accelerate that by, one, building out infrastructure services like Geodnet, but also helping with things like mapping and training data that are needed to bring these services up in different environments. You can imagine if I take that car in San Francisco and I move it to New Delhi, it's just not going to be able to drive effectively without a tremendous retraining. This is where DePIN can come in as a data collection layer, as an infrastructure layer to provide services and make these solutions much more scalable.
So, Mike, I know you touched on this a little bit. In terms of the physical AI thematic and the trend, what role Geonet is playing? Can you specify with some of the examples that Geonet can enable?
Yeah, so Geonet's first and initial role in this is to provide a hyper-precise location services. So drones, autonomous vehicles, robots that are working outside need to be able to localize to, some people say within 10 centimeters, for some applications actually within 1 centimeter. You can imagine like a robotic lawnmower in your lawn. Even a few centimeters of error in its position is the difference between mowing your lawn and running over your flowers. So hyper-precise location is a very powerful tool in the development of robotics. You can build maps from that. You can do obstacle avoidance. You can work in conditions where you might have no visual line of sight. So some things like cameras and lidars are also super powerful sensors, but they have weak points in terms of, lighting conditions and types of materials that they may not bounce off of well. So RTK, real-time kinematic, is a way to sort of blindly know where you are to within a centimeter. And that's very, very powerful for AI to do its job. It gives it that sense of context to know what to do where. So that's the primary role that we're playing today. And we're providing service now to multiple different customers in drones, multiple different customers in ground robots, multiple different customers who build actually sort of fundamental chips, the GNSS chips that go into all kinds of devices, from phones to cars to anyone who wants to get access to hyper-precise location can go to one of our chip partners, buy the chip, and connect into the Geodnet service. So quite a wide range. But I do think we're going to push deeper in 2025 into services specifically around drones and robots, building on top of the base RTK, providing services like PPK, map building tools, things that every robot platform needs. And you'll see that from
Mike, what
us.
is PPK?
PPK is basically when you use RTK but in post-processing. So a very common thing in the world of sort of smart cities and digital twin creation is to go out and collect tons of data, LiDAR data, camera data, GNSS data, then bring all that back and process it in a way to create a 3D model of the world. And that workflow today is pretty high end. It's not something that's super easy to do, but it's being done by numerous entities around the world to build these smart digital twins. We're going to make that process much easier. It actually even ties into what we've been doing with GeoPulse. GeoPulse is kind of a little training device. GeoPulse has many roles, but one of the roles is playing for us. One of the benefits that it's bringing to the demand side of our network is data that allows us to train up our PPK models to work very efficiently.
So, Mike, in terms of the goals you have for 2025 and also some of the physical AI use cases you have, can you specify some customers that you have already onboarded, those you can name that are using your services within that physical AI thematic?
Yeah, so let's start with drones. So within the drone industry, we have Propeller, which provides mapping and planning services for construction environments. So this is a way that people are automating and kind of getting better information services in construction. We have Drone Deploy, which is a wide network that it's really cool. The Drone Deploy application lets you basically go out to a job site and it's sort of pre-configured to fly the mission, so it robotically will fly for you. So very similar to some of the things that the goals of the Spexy network are, just in a Web 2 context. We have multiple different robotic mower platforms, including Verde, Sensori Robotics, and a couple I can't name, that use the Geodnet service for robotic mowing and landscaping applications. And then we're also in a lot of sort of automated agricultural applications. So Burrow.ai, Deep Sand. We have a partnership with the USDA where they're helping test and evaluate a lot of this equipment and provide research data to them. And they're also running a Geodnet node. So there's a quite some different use cases in industrial, IoT, and drones that are already using Geodnet today.
So within the subsegment of physical AI, Mike, apart from Geonet, what are some of the other DePIN projects you're seeing that is kind of operating in similar vertical?
So I think that obviously there are mapping protocols, and I think mapping protocols are pretty tightly related to positioning protocols. So we've done a lot of work with Rover. Rover's building specifically HD map data products, and these really combine LiDAR and RTK to actually produce 3D HD maps that can be consumed by autonomous vehicles. And autonomous vehicles is a really important area. Geodnet already, I should have mentioned it before, has people who consume our data and then do certain qualification on it for automotive safety integrity level type of requirements, and then provide that as corrections for ADAS systems. And that's another area of demand. That very much ties into this need for HD map data. As these systems try to navigate more complex environments, you're not going to always have GNSS. So sometimes you're going to need to rely on your understanding of the world that as seen through things like cameras and LiDAR. And to do that, the proven way to do that today, the way that Waymo does it, and most of the level 4 type of autonomous vehicles are doing it, is to build HD maps of the world. And we've even seen folks who have initially taken a very skeptical view of HD mapping start to actually turn over and say, yes, we need HD maps in order to enable safe, full level 4 type autonomy, full self-driving as they call it. And if you study some of the blogs and news, you can sort of infer what's going on at some of the big name companies that have often said, hey, LiDAR, HD mapping isn't needed for autonomy. I think that the tune is changing on that. So it's really, that HD mapping integration, I think, is a very important protocol to work with. We've also been engaged in aviation-related protocols. So the aviation network relies a lot on ADS-B data. These are position broadcasts from aircraft that then tell at a large area coverage long before you're on approach into an airport, tell you where the plane is. So there's a protocol, Wingbits, that we have a close partnership, and we've actually developed a dual mining station that will mine the Wingbits data as well as the Geodnet
we'll
data.
get into that. Yeah, we'll get into that, Mike, in a moment.
Okay.
So even with the aviation, like you mentioned Wingbits, does that come under the wing of physical AI?
I think so, because your air traffic, maybe not so much, but the drone aspect does. So one of the things that's happening right now in the United States, and it's already being done legally in other countries, is beyond visual line of sight drone operations. So this is a drone that can do drone delivery. This is a drone that can take off on its own without being monitored and supervised. So for an AI agentic type of drone to happen, it can't have a sort of human master all the time. As part of that, FAA has stipulated in its initial guidance on what's called FAA Part 108 the technology that needs to be in these drones as a sensor technology is see and avoid, and a situational awareness of the aircraft that are around it. ADS-B and Wingbits is a great tool to provide that. So shortly after this initial launch of that network, we'll be adding remote ID, which will create the first terrestrial network to scaled terrestrial network to absorb drone remote ID data, and then be able to provide that into the AI inside the drone in order to give it that context of what's around.
So your partnership with Wingbits is around that, if I'm not mistaken.
It's around multiple aspects. So there's the having a device that can mine both the network topology of Wingbits and Geodnet's quite similar. So there's leverage for the supply community, the mining community, to be able to put up one station and get 2 different token rewards and perform 2 different utilities off one rooftop. So there's an element of that. There's an element of this physical AI around drones, that this is an important piece of infrastructure and service that for drones to actually be kind of agentic and do their own missions on their own without a human master, this service has to be there. This drone monitoring capability and see and avoid technology has to be there. And then there's also a piece that maybe you wouldn't necessarily call physical AI, but I do think it's an AI capability for aviation in general that is being safe. So there's a lot of GPS signal interference, GNSS signal interference going on. Aviation is at risk all the time of being kind of spoofed or jammed, and there are a lot of areas where GNSS-based approaches is the only way in. So having this ground network that has an integrity function by looking at both the satellite data, but also looking at the ADS-B broadcast data, knowing where the stations are, being able to triangulate if the aircraft is being spoofed or jammed, this can provide an intelligence that can help the pilot navigate safely through more complex airspaces and more contested airspaces, which is happening now throughout the Middle East and throughout the North Atlantic. So, and this is all core. What I'm talking about here is all sort of core things that Wingbits is working on, and it's super exciting to see all the progress that they're making.
So, Mike, it's kind of interesting to kind of think about it as DePIN bundling, like this one device that allows you to mine Geo and also a potentially Wingbits token. Are there other bundled partnership or project that you guys have in pipeline or are working towards?
Yeah, so there'll be two new ones that we're going to talk about at Ethereum Denver. One I can share a little bit right now on is Decharge. So we think with robotics, right, there's a need for energy. Robots they have weight limitations. They can't carry infinite amounts of power. So we're really excited about decentralized charging infrastructure. We formed a nice relationship already with Decharge. They're already bundling Geodnet with the charging stations for traditional passenger vehicles, but we can look forward to charging stations that are more specifically geared around robotic applications. And you can look forward to that in those applications, a deeper integration of Decharge and Geodnet.
So, Mike, you mentioned Venmo earlier. That's one of the projects in the physical AI that you're kind of excited about. What would be on the Web 2 side, not Web 3 side, so the other project you would think are interesting to kind of look at from an intellectual perspective within the physical AI space?
Well, certainly dogs are a really useful tool. Humanoids are also super cool. So we do have activity going on in both humanoid robots and robotic dogs. One of the things I like to always emphasize about robotics is the humanoid robot is definitely the most fun. I mean, let's just be clear. It's the most exciting. It's the most interesting type of robotic platform to think about because it's so similar to us. But in many ways, at a business level, it's often useful to think about what are our limitations and what are the things we're not good at and how can we design around those biological limitations to create an even more powerful robot. So we have eyes, which are essentially cameras. LiDAR is this incredible sensor that you can use for 3D visualization. So I think LiDAR is a better sensor than cameras for certain aspects of the job. You definitely need cameras too, but it gives a capability to a robot that is beyond human, right? And so when you think about platforms, I really get excited about platforms that combine human characteristics with also, non-human characteristics. So, for example, wheeled humanoids, where you have a base that is wheeled, but you have arms and physical actuators to do things with, your hands and your arms. This is an incredible combination because you're kind of getting the best of a car and a person all at the same time. So I think there are a lot of those variations out there we're lucky enough to be working with some of the top hardware companies in the space to understand how we can bring our sensor technology into those platforms and help those businesses scale. So dogs, today are actively being used quite a lot in the survey industry. So when you need to go survey an outdoor area that may be quite physically challenging, you need to do a ground survey. If you can scan it with a drone, perfect. Scan it with a drone. Fly over it, can do it really fast. But what if I need to build a model, inside the building, or what if I need to build a model inside the forest, so to speak, in rough terrain conditions? Doing that, collecting that data, you can't drive a car in these areas. You can't walk and create the density of 3D replica that you want. The dog becomes an incredibly useful tool in those environments. And that's why you see these dogs popping up more and more in these crossover sort of surveying applications. And that's, always a combination of a visual sensing, RTK, and then the robotic platform itself. So this is a very great area for Geodnet. We've already started working on collaborations in this space, and we'll be showing off more and more of that throughout 2025.
Mike, taking a gear back towards DePIN, what do you think is holding DePIN back? We have looked at L1s, we have looked at DeFi, both have achieved product market fit. It kind of seems, at least from a market cap perspective, DePIN is kind of holding back. What do you think are some of the challenges that kind of DePIN founders face, and it kind of holds them back, and even as a sector, it's kind of holding it back?
One key aspect is just that when you work with the real world and you interface, you're bridging Web 2 to Web 3, and we're really working core on the demand side with Web 2. There's just a little bit different timeline than there is when your product like DeFi is primarily servicing other Web3 protocols, and maybe even things like meme coins that can kind of instantly go viral and take advantage of social media, because there's no there's no physical thing that you're plugging into. There are no regulations, there's no testing, there's no safety, there's no tie to the real world, there's no data quality concerns. There's obviously, you want to make sure the transactions work and are smooth, and things like Solana and DeFi protocols have done an amazing job of making that super easy, but there's nothing really tying you down. So I think that's the thing that slows DePIN down, but it's also the thing that creates an enormous moat to the networks that are successful in the long term. And it's also the thing that allows it to bring actual real Web 2 dollars into Web 3, as opposed to just recirculating the same pool of money that does happen an awful lot in crypto. So you see some things go up, and then you quickly see other things go down, and then those things come down and other things go up. It's like a wave pool. I think a lot of crypto is like a wave pool, and it gets very exciting when you're on the rising wave. It really sucks when you're on the down wave, and DePIN is not like that. DePIN takes more time, but it's actually bringing in real economy into Web 3 and really building, I think, sustainable long-term businesses. So in some sense, the biggest challenge is just the crypto and Web3 market has become accustomed to kind of a different set of physical dynamics or economic dynamics that are very, very fast moving and very quick to rise and also very quick to fall. DePIN just isn't really that.
So Mike, double clicking on moats, let's define DePIN as having some sort of a physical component. In your opinion, what type of moat is the strongest to have if you are building a DePIN network? Like, what's one thing you would optimize for in terms of building a moat within this type of a network?
Well, I'm biased, of course, but I think all these protocols that involve geospatial and a need for data and a need for connectivity or data collection that is physically decentralized are particularly powerful, because achieving physical decentralization using a centralized approach is enormously expensive no matter how you cut it. And being able to do that through a protocol is enormously efficient, and it speeds things up. It reduces costs, but it also speeds things up by orders of magnitude. So I particularly do like projects and protocols that have a decentralized physical aspect, because I think that's a very powerful mode.
So if I were to summarize it for the audience, it's the decentralized nature which increases the replication costs of the network. Is that what you're alluding to in other words?
And the coordination costs. So if you want to coordinate a centralized deployments of physical infrastructure throughout the world, and you're not using a DePIN-based approach, you're going to find that it's extremely slow and tedious. As an example, before we started Geodnet as a Web3 protocol, one of the three co-founders of Geodnet, and myself had looked at renting space on these self-storage locations. Could we put GNSS stations on self-storage locations? Well, first we had called American Tower and Crown Castle, and we had found that was just way out of the expense bucket that we could pay for to get the density that we need. You would have to locate the GNSS station at the top of the tower to avoid interference from the metal tower itself and to avoid interference from the LTE. That's the most expensive location on the towers. And it's just enormously expensive proposition to do it that way. So then we look to self-storage locations. Self-storage locations are a little bit lower cost, but each location you need to pull internet to that location. You need to have a civil engineer come out and create drawings, have a city inspector come in and check it, and try to do that. And of course, self-storage is common in the United States, but it may not be as common in Latin America. It may be a different set of political, regulatory issues. It's just enormously complex and expensive to try to coordinate that centrally. With a protocol-based approach, you set up a set of rules as to how these stations work, how they validate the integrity of the data, how they're going to plug into the bigger network in an autonomous fashion, and then you let the market go to work, and these things get acquired and set up all on their own. It's hard to describe how much more efficient it is, and at the same time, it is creating the end product that people need to deliver. To be able to utilize. And then another big benefit is that the people who have participated in the creation of the network, share in the upside of the network. So on all levels, it's just a far, far superior model to build out these decentralized physical infrastructure network services.
Just a quick question on top of my head. Let's say if you weren't taking a decentralized approach, if you were taking a centralized approach, roughly speaking, what would the unit cost be of setting up one node on an annual basis?
Best case, what we were seeing was just the initial setup cost, not the recurring cost. The initial setup cost, best case would be $5,000 for the installation, an approval process that was needed by someone like a self-storage, and plus the cost of the hardware. In the Geodnet's case, we've also innovated tremendously on the cost of the base station hardware. So a traditional base station today runs anywhere from $10,000 to $25,000. There's a podcast I just did with Brad Stearns, one of our users, and he mentioned that one of his friends was about to acquire a RTK base station for $14,000 before he introduced them to Geodnet. So we've also innovated a lot on the hardware, and I think you do see a lot of DePIN protocols working very hard to innovate on the hardware. And then obviously the deployment model is just totally different as well, and allowing for quick deployment, allowing for the network to scale in an autonomous fashion. These are the real core things that the DePIN protocols are bringing to bear to create utility.
So just a TLDR, what's the rough cost saving using, let's say, Geonet?
It's probably over $20,000 per station, baseline, and not including the recurring cost. And then you got to look at the recurring cost, which just depends on the leases you negotiate. For top of tower leases, those can be $10,000, $15,000 a year easily. I posted on Twitter some numbers. You can just Google up cost of American Tower lease, and you can see the range of prices it comes up with. It's very expensive. Scale that out to 20,000 nodes, and you're going to have just an enormous bill. And American Tower doesn't cover every location on the planet. I mean, geospatial in particular, some of the things that you see. I was on a panel with Hivemapper, Helium, and myself and the Solana Foundation at Solana APEC last week. And all three of the protocols, Helium, Hivemapper, and us, were talked a lot about sort of work in Latin America and why Latin America has opportunities, because in the case of Hivemapper, the story was Google won't update the maps there for Mexico City, and it's very difficult for the drivers. In the case of Helium, there's a need to build out more data offload infrastructure, and the CapEx isn't there to do it, so it becomes very attractive. In our case, a lot of it's about agriculture. There's big agricultural regions in Latin America and Brazil and Mexico that want to use precision farming and don't have access to that technology. DePIN can solve these problems in a way that centralized solutions just don't. And it was great to see on that panel that all three protocols had a similar story of how they were able to really provide something that a centralized solution couldn't provide in a more developing world economy.
Mike, just to elaborate more on the fundamental side of the business, tell us more about your traction, your revenue numbers, and how does the monetization work here?
So revenue is doing good and growing. We have now, I think, 30 different signed business agreements, adding a business agreement about a week. one a week these days. I think this week we added 2, so it's really coming along. We
So
have
on
2.
ARR basis, what would you say
We're on
is
ARR
revenue?
today. We're at $3 million. It results in buyback and burn of about $2.5 million at the moment, and that's going to continue to grow. We hope. Obviously, things could go wrong. The network could crash, but as far as we can see, we have a lot of customers and not a lot of complaints about the network. UDAN and Amr were out at GeoWeek this week, meeting with several of our existing customers and partners. A lot of great feedback. We actually gave out a bunch of trial accounts at that event as well. And the number of those were tested like the same day. And people were just stunned at how efficient and how well it works. And that's what lets us add subscriptions sort of continuously all the time, and well as bigger partners. We do have a wholesale model, and also what you could think of as similar to sort of the Helium's data offload model. And we also have a resale model where a person can become a reseller of the Geodnet network. Maybe I'm selling drones, maybe I'm selling construction equipment, I'm selling robots, and I want to bundle the Geodnet subscription with the device, and we do a revenue share. Both of those models have been working extremely well and growing continuously.
Awesome. So this 3 million ARR, just to double click on that, is coming from subscription, from data purchase. This doesn't include the hardware sale that
Absolutely
that goes
not.
through.
It's pure data subscription. It's just what you said, subscriptions and data wholesale data services that we provide.
And what about the traction in terms of number of nodes that are out there, and at what capacity? At what point you're thinking in terms of timing wise that you will get complete global coverage?
So we're doing extremely well on coverage in North America and in Europe. We are, I think, 13,000-ish registered nodes so far, 12,000 or so operating stably, 200 to 300 being added a week. It's no RTK network has ever grown anything like this. We are, in terms of station count, by far the largest in terms of in any major urban area will be the densest network, which means you have the shortest baseline, which means you'll get the best, most reliable position at the shortest possible length of time from startup, and also the best vertical accuracy, which is really all these things really matter in these applications. So it is the world's largest RTK network today. And we definitely think that when we pass 20,000 nodes, you're starting to reach a point where, for practical purposes, you can say you have full coverage in the markets that we're legally allowed to serve. And we'll start to think more and more strategically about how to create incentives to cover small gaps in regions that may be less important today, but more important in the future, or where there's just a small area that doesn't provide quite the same level of quality. We're building monitoring tools. A big push this year for the Geodnet network is building a lot of data reliability and monitoring tools to get down to very, very fine grain level of SLA guarantees for customers. And we're going to work to align incentives to do that as well. But overall, the network's extremely reliable and really robust, and you'll hear customers say it works better than anything they've ever tested before frequently. So I think we're in a good spot. We're just going to keep after it and keep driving using the DePIN flywheel cycle to keep making the network better and better.
Mike, as a compliment, seems like you guys have a monopoly in the RTK network. At least it seems like that. What would you say is the second largest RTK network, and who kind of owns that RTK network?
So there are two big ones that I think are widely used in the traditional applications. There's Hexagon's SmartNet, and then there's Trimble has a variety of different data products. They have what's called VRS Now. They also have a network called RTX. These are two of certainly the most famous networks in the traditional industries. And then there are networks in more IoT and automotive, Swift Navigation, Point One, uBlox's Point Perfect. Now, I can't go into a lot of specifics on these things, but some of these networks like to use Geodnet as well for wholesale data services. So it's a continuum. The geospatial space is pretty intense, very performance-driven, very technical. These things have to work. They have to work extremely reliably. And so that leads the engineers and the teams that are in this business to usually be pretty friendly with each other and support each other, because they may have different markets that they're better at than, say, a decentralized protocol can be at. So there's no reason an open protocol like Geodnet can't collaborate with existing people in the marketplace. And that's been an effective strategy for us, and one that we're very open to more collaborations to help existing players as well.
Mike, everything I'm hearing right now sounds amazing, sounds great. Just to add a little bit of spice to the podcast, What would you say is the bear case for Geonet?
The bear case would be, and we're working on the bear case, but, some new technology comes up that's even more accurate and more precise that uses new types of RF signals and ways to kind of create centimeter location. So we look at this all the time. There's nothing on the horizon that's remotely as good or scalable as RTK to create centimeter positioning in an outdoor environment, but there are things like in indoors that we're very interested in that we're working on. There's new types of satellite technology. We have partnerships there. Some of those will be announced later in the year for new kinds of satellites that we're super excited about. We try to be out ahead of that. I think the bear case is some new technology comes out that's better. And that's, of course, our passion is to figure out what those things are, because they're in the end, they're going to need DePIN. I think go back to my original comment about why geospatial, anything that's going to need to scale out globally that is going to provide high accuracy positioning and localization, you're going to have an element of it that needs DePIN, whether it's a training, whether it's infrastructure. These things are all going to depend on that DePIN cycle. And so we think we've started to understand how to make a protocol and DePIN work well. And so we're open-minded to new technologies as well.
So, Mike, in terms of that technology, what would you say is the second best that's coming closer to that accuracy? Is it more satellite-based? Is it more mobile-based? Like, what platform is that type of positioning taking? In terms of the second best, not the...
Yeah, I think for sure the second best technology for localization is taking an HD map and using a LiDAR. So if you have a already pre-mapped area with an HD map and you have a LiDAR, you do a convolution of the point cloud that you get in real time with the HD map, and you can localize yourself to centimeter accuracy without any RF dependence. So this connection, if you go to a show like Intergeo, which is a huge show in Germany every year on geospatial services, that show now is like half RTK and half LiDAR. And so that's why you see such a close collaboration between Geodnet and the Rover protocol, because Rover is really bringing out a low-cost LiDAR-based device that can be utilized. And we think that combination is very powerful. So I would definitely argue that LiDAR is the second best technology. It isn't an absolute. So one thing to also keep in mind, it doesn't give you an absolute position. It's for relative positioning, but very accurate relative positioning to know how wide the door frame is, to be able to walk through the door frame, especially in indoor contexts. LiDAR is a very powerful technology. Its cost is coming down. Understanding how to use it, train with it is improving. So I think that's very complementary. There are other cool tech that we like a lot. UWB is a radio-based technology, can be used indoors that we've been studying and looking at quite a lot. How to do RTK plus UWB combinations is very cool. And of course, there's camera-based localization as well. And camera is really, I think, the most important sensor for sort of perception and for decision-making, sort of higher levels in the AI. It's a little tougher for localization, but it can be used in localization as well. But I think LiDAR has an advantage over there just because of the very accurate depth sensing that it provides, right? You're getting millimeter level returns on LiDAR in depth. And so, combine that with a HD map or SLAM, it's very powerful.
Mike, before we conclude the podcast, was there a question I should have asked you but didn't?
Well, I would like to get your take, Mehdi, on the whole DePIN. Why hasn't this narrative kicked in faster? Because to me, it's one of the most obvious utility generating things in all of Web3. I think it should be the biggest, quite frankly, category in Web3 because it has the most utility. But it clearly hasn't yet. I think it will come. But I'd like to hear I'd like to understand a little bit about what you think is sitting on the investment side and having worked with all these protocols. Why hasn't DePIN caught fire faster from a market cap or token traction point of view?
One thing I would primarily say is distribution of the token. One mental model is thinking over the product and the token separately. I think what happens is, for whatever reason, it has been a little bit of a struggle for DePIN to get that token distribution with the exchanges. So getting those tier one exchange listings that basically gets the token into the hands of other people. If people make money, they speak about it. That has that momentum. There's a blessing and a curse with revenue as well. So one thing that happens in crypto is, let's say if you have revenue numbers, people can start attaching fundamental valuation to it, which is great, which is awesome. You should do that. But let's say if you don't have valuation, if you just have story, or you just have unpotential growth and narrative, there isn't a valuation, and basically sky's the limit. So based on those things, the token tends to do well, but that doesn't necessarily mean that the business is that great. So what we see in crypto is for a few years, maybe for a couple of years, those tokens do really well, and then we slowly see the fundamentals and the reality catching up to it, and then those token prices fall. But in case of DePIN, what has happened is, I personally think we haven't even had the chance, apart from maybe one or two projects, that one project basically goes mainstream, even in terms of token price action. So we haven't seen that drop either. I think that's my mental model. I think crypto is very retail friendly, and I feel like there is that retail element that also needs to be appealing. But that being said, I like DePIN. We have a position in Geonet, and yeah, the fundamental story makes total sense. And then thing with DePIN is, if you have conviction, it's easier to hold than, let's say, some other stuff which is based on mimetic.
Makes sense. Yeah, I think we DePIN founders tend to also be very focused on our utility and our problems, and the problems can be pretty technical, and that definitely creates a rub with a fast-moving retail audience who would like to understand things. And Trump coin only takes 1 second to understand that token, at least from the idea of whether you like it or not. Most people will decide on that probably within a few seconds. So DePIN, you need to understand things a bit more. I think that's a friction point. And then the distribution, as you said, is also a big factor. So we're looking to improve on those things. I think that the good thing is the utility is there. That's really the big strength of DePIN. And I've seen in our thing, we try to share this as much as we can. Every customer is not, some customers' privacy is very, very important to them. So we can't get every single customer that we have to sort of reflect on why they like Geodnet. But we do try to get the ones that we can to come out and talk and share, because it really is all boats rising together. It's a team sport. When the Web3 is successful, it makes the Web2 businesses go better. When the Web2 businesses go better, it makes the Web3 businesses go better. So it's a real, I think there's a lot of win-win going on, and that's nice. In a lot of cases, business isn't win-win. It's kind of win-lose. And I feel like with DePIN, there's a lot of win-win going on and across Web 2 and Web 3.
Mike, this was such a great episode. I learned a ton. I got the updates about Geonet. Thanks for coming along.
Thank you, Mehdi, for having me.